Hi, this is the problem set video for problem set 4 task 2, which is called RPS rounds for rock, paper, scissors rounds. So in the last problem set, we built a rock, paper, scissors game. You input a gesture via a parameter, rock, paper, scissors, and then the computer decides on a random gesture, and then it prints out a message telling you whether you won or lost. But rock, paper, scissors is usually played in 3 or more rounds, where it's like best of 3 or best of 5, and you play multiple times against each other. Um, and the game actually becomes much more interesting in that context because the two people have a chance to sort of guess each other's mindset and adapt. And now that we're studying loops, we have a great way of telling code that it should repeat. And in particular, while loops are good for telling code that it should repeat indefinitely until a certain condition is met. And so in the case of RPS rounds, we will be using while loops in 2 places. First, we'll be using while loops to get input from the user. Instead of having it be a parameter to a function, we're going to call that input so that you can type in your input when the program runs. And to do that, though, we need to make sure that the user gives us input that is correct input, right? If the user types dinosaur, then we don't really know what to do with that. So we're going to have a while loop that keeps asking the user for input until they give us rock, paper, or scissors, right? Something we can work with to play the game. And then we'll be using another while loop to keep playing the game until either you or the computer win a certain number of times. And so this is not like best out of 3 or best out of 5, really, because ties can happen, right? So you could have 100 ties, and then you win twice. And then that was, 102 games, but the score is only 2-0 with a bunch of ties on the table. So we need a loop that will keep going until that condition is met. One wrinkle is that the starter code we provided for you is incomplete. Part of what you need for the starter code is the solution to problem set 3, task 3. And since this problem set was released before that was available, you have to copy paste some code from that solution file into your code. So there's a link here that you can follow to access that solution. And this link sort of went live when the revision period for problem set 3 ended. And so at this point, when I'm recording the video, you should be able to already go and visit that link and copy paste that code into your starter file. There's a place that has a comment that tells you where to paste it, and then get started on the rest of it. So here is an example of what the output should look like. And we're linking you to this diff checker website yet again that we've linked you several places now in this course, right? As a useful tool for being able to take text like this and check it against the real output that you get to make sure they're exactly the same, right? And typically for the extra goals, we do require that you are basically getting everything exactly correct, down to the parentheses and the spaces and all the little details, right? Although for the core goals, we don't require that. So it should have these messages that you're playing and how many wins you're playing for. The parameter to play RPS is the number of wins required to enter the game. It has these instructions at the beginning, and then it prints these 3 dashes, and then it prints information about a single round. And you may notice that this text here looks suspiciously similar to the text that we printed out in the last assignment. And in fact, it comes from that same function, play computer. Except this time, in the solution code, we provided not only the basic solution, but an extra function called playComputerFruitful that you'll need, which not only prints a message, but also returns a string indicating the outcome of the game, which is necessary for your code to then record that outcome and figure out how many wins, losses, and ties there are at every point in the game. So if you choose rock and the computer chooses scissors, which is still at random, then you win, and now you have 1 win at the start of round 2. Right? We start with round 1, then round 2, then round 3. In this example game, here's an example of how the gesture validation works. If we enter an invalid gesture like ZZZ, Then there's a message that says, sorry, we could not interpret that input as a gesture. Please enter one of rock, paper, or scissors. And then if we continue to enter invalid inputs, that will continue to happen until we enter a valid input. Notice that we are ignoring case here, right? So lowercase rock, capital rock, uppercase paper, all uppercase, mixed cases. We don't care about case. We care about the string being one of rock, paper, or scissors. And in this example game, we played to 2 wins, 2 losses, 3 ties. We won, and then we went up to 3 wins, and that was our goal of 3 wins to end the game. And so that is the end of the game. Here's another transcript showing just how get gesture works again. If you enter something invalid, then it will sort of keep telling you, hey, you have to enter one of these things. And when we do, uppercase or lowercase, that function will return the lowercase version of the gesture that we worked with, that we entered. So your task is to define get gesture and play RPS. That's it, right? And just define them according to their behavior as described in this example output above and as I've been describing in this video. There's some notes to sort of help you think about it. One, because the number of moves cannot be determined in advance, you don't know how many ties there might be, you can't use a for loop for this. You have to use a while loop, right? Because a for loop loops over a fixed finite sequence, and a while loop loops until some condition becomes false. Excuse me. This note is actually out of date. And it should have been supplanted by the other note up there that's saying that you need to download that solution code. Okay, to satisfy all the extra goals, you have to do the following. We've provided plural and state summary functions that do some little string manipulation to make things just a little bit smoother in the English so that things are pluralized correctly. For example, when there's 1 win versus 2 wins, right? We have functions that help you with that. You have to use those functions correctly in order to get 100% correct output. The user gesture should be allowed in any mixture of upper and lower case, right? Use the .lower method for this. And then you have to match the printed strings exactly. The example above shows what the output should look like at the end. Congratulations, you won 3 times if you won the game. This example down here, too bad you lost however many times, is what things should look like if you lost the game. And you know, again, use these plural and state summary functions to generate some of these strings. Testing for random things is always hard, right? And if testing for interactive things is also hard, you should definitely test it with different parameters. You don't have to worry about the number of wins being 0 or like a negative number. Those are not valid inputs, so we won't test with those. But any positive integer, any non-negative integer, any positive integer above 0 is fair play. And then a hint to make testing easier, you can temporarily tinker with the definition of random gesture so that, say, it always returns rock. You know, make sure to disable that before you submit your code. But you can do that, and then when you're testing it, you'll know what the computer will do. So it's easier to, you know, play for a specific number of ties and then a win or a loss or whatever you want to do. All right, let me walk us through the rubric, and then we'll be done with this task video. The rubric for task 2, the core goals are, number 1, our friendly all functions are documented goal. Number 2, the results of get gesture are correct. So we're going to test your function in several contexts. We're going to provide it with fake inputs and see what it does, and hopefully it does the right thing. Results of play RPS are correct, right? So we're going to call that function with fake inputs, and we want it to print the correct output. We have to define get gesture, and the restrictions on get gesture are it must use a while loop, and it must call input in at least one place in that while loop. And then either it must call print at least once or call input at least twice, right? And this is a either or, even though these both are listed as goals here. If you satisfy at least one of these goals 8 and 9, goal 7 will be satisfied, and then goal 4 can be satisfied. Okay. So you have to define play RPS, and in that definition you have to use a while loop. In that while loop, you must call getGesture and playComputer. And actually, I'm going to double check this goal. I think we require you to call playComputer fruitful, the new function that we provided that actually returns the value. All right, extra goals. So the results of getGesture should be correct. We're going to throw 7 more tests at you, and then 10 more tests for play RPS. Right? And you can imagine some of these tests are the sort of more tricky cases that you might not have thought of. You have to define getGesture, and for the extra goal, you have to call input in exactly one place and print in exactly one place. And this is quite tricky to get working. It requires a little bit of clever thinking about while loop conditions. And then you have to define play RPS, and for the extra goals, you are not allowed to call random gesture, which is not something that you should be calling inside of play RPS anyway. You should call print in at most 10 places. You should call plural in at least one place, and state summary in at least one place. So those are all the goals for problem set 4 task 2. I am going to go ahead and revisit this one, which I think should read called playComputer fruitful, and maybe update it. That's it for my video.